All right, today we're going to start Unit 2, which is transformations, triangles, and quadrilaterals. Today we're going to focus on transformations, and that's what Fluency 7 is going to cover. I will talk about the date of Fluency 7 when I get back on Thursday. All right, so Fluency 7 contains a bunch of topics. Today we're going to talk about transformations. Then tomorrow we'll talk about translations. Then we'll get into reflections, rotation, and some symmetry, and then composition. All right, so today the notes aren't too long. We're going to talk about transformations, but the first thing I want to do is I want to work with the daily warm-up. All right, so we have already simplified square roots when we did distance formulas. So we need to break this square root down. And remember, we don't want to just break it down into any numbers. We want to break it down into perfect squares. So remember, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and then 10 squared is 100. So those are our first group of perfect squares. And what we want to do is we want to look for numbers that divide evenly into 98. So I always start with where would 98 fit in this list. It would start here, it would be somewhere here in between 81 and 90. Well, 81 doesn't divide nicely in there, 64 doesn't divide nicely in there, but 49 does. So I can break this down into the square root of 49 and the square root of 2. When I multiply these square roots together, I get square root of 98. All right, so then we can simplify square root of 49 because that was on my perfect square list. So that becomes 7 square roots of 2. All right, and like I said, we did a bunch of the work with this when we were doing the distance formula. All right, looking over here at what we call function notation. We haven't done any of this so far this year, but f of 4 is what we're looking for. And the nice thing about this 4 is when I look over here, f of x is the equation 2x minus 5. So I know that the 4 replaces the x in this equation. So we're going to go to this expression right here, and we are going to plug 4 in everywhere we see x. So to find f of 4, we're going to take out x, we're going to plug in 4. So we're going to do 2 times 4 minus 5. Well, we know 2 times 4 is 8, and 8 minus 5 is 3. All right, so f of 4 is equal to 3. And all we did is we went to the expression and we plugged in 4 everywhere we saw x. So if I wanted you to do f of negative 1, we would plug negative 1 in everywhere we see x. If I wanted you to do f of positive 1, we'd plug in positive 1 everywhere we see x, and then simplify. All right, so let's talk about transformations. All right, so we got some definitions here. It says a transformation is an operation that maps an original figure called the preimage. So the starting figure that we're given is called the preimage. And then we're going to move it, or we're going to change something about that figure, and that new figure is going to be called the image. All right, so there's a couple different types of transformations, which we're going to talk about over the course of the next week. But a transformation can change 3 things. It can change the position, so I can move it left, right, up, down. It can change the size. I can double it. I can shrink it by half. Or it can change the shape. All right, so it changes the position, the size, or the shape. All right, and there's 2 different types of motions that we could do when we're doing our transformations. The first motion is called rigid motion, and that's when a point or an object is moved, but the size and the shape stays the same. So it doesn't get bigger, it doesn't get smaller, you are physically just moving it, whether it's an object or a point. And then if it's rigid, the non-rigid means when you do change the shape or the size of the object. So whatever movement I ask you to do makes the shape bigger, makes the shape smaller, but it changes the shape or the size of that object. So rigid moves it, but it doesn't change the size or the shape. So it could move it left, it could move it right, it could move it up, it could move it down. All right, but then non-rigid does change the shape and the size. All right, so we only have 2 examples for today. It says draw each image on the graph to show how the pre-image is transformed by the function. And then it says classify that transformation as rigid or non-rigid. All right, so the first thing we need to do is we need to look at some notation over here. So every point in this graph on the left side, or our pre-image, right, our starting graph, every point is represented by an X and a Y value. All right, so what we're going to do to the graph is we're going to do what it says after the arrow. We're going to transform it. All right, so what this graph says is we are going to take the X's and we're going to add 3. But in this case, we're going to leave the Y values completely the same. We're going to leave them alone. So this means leave Y's alone. Now, I could have Y minus 1 there, and then we'd take our Y values and we'd subtract 1. All right, so there's a couple different ways to do this. What I'm going to do over on the graph on the left is in orange, I'm going to trace that original picture. So the first point, this is over 2, up 2. So over 2, up 2, I have a dot. And then it goes 1, 2, 3 higher than that. 1, 2, 3. And then it goes 1, 2, 3 across. 1, 2, 3. And then down 3. So there is my pre-image. All right, so now what I want to do is I want to take every single one of those X values. I want to add 3 to it. So here my X value is 2. If I add 3, I can just move it 1, 2, 3. And my new X value goes there. Right? I'm not changing my Y's, so it doesn't go up and it doesn't go down. All right, I'm going to do the same thing with this X value down here in the bottom corner. I'm going to add 3, 1, 2, 3, so it moves to there. All right, now I've got to take the endpoints, which started, I'm going to switch colors here, started here, and I'm going to move it 1, 2, 3, so now it ends there. I'm going to move this one 1, 2, 3, so now it ends there. So in blue is my new shape. Okay, so if you look at the pre-image, which is the orange, so this, I'm going to say PI for pre-image, and this is my image, my new graph. I took every X value, so if I took 2, and now if this point right here was at 2 for X, and now it's at 5, I added 3. The original value down here was at 5, and now it's at 8, so I added 3. So I basically just shifted this box. All right, so now it says classify the transformation as rigid or non-rigid. So remember, rigid means the size and the shape stays the same. So if you look at this box or the square, it clearly looks like the same size square. We just slid it over, right? We just moved it. So that means this is rigid motion. All we did was move it over. Okay, we shifted it right 3. We did not move it up and down, but I could have moved it up and down. Then I would have just shifted every point right 3 and maybe up 2, or right 3 and down 1. All right, so taking a look at example B, this one looks a little bit different. Now we're going to start with the original points x, y, but then we're going to do 2 times x and 2 times y. All right, so let's take a look at our original graph. Our original graph, the x value, so this point right here is 1, and it's up 2, so 1, 2. This one is over here at 1, 2, 3, 2. Up here is 1, 1, 2, 3, 4, 5. And then this is 3, 5 as well. All right, so one way to do this is we could write the points. So I could make a table here, and I could say, hey, what are my 4 points? My 4 points are 1, 2. So that's that bottom left corner. And then I also have 1, 5, which is the corner all the way up at the top. All right, I also have the point 3, 2, which is the point on the far right on the bottom. And then up at the top, I also have the point 3, 5. All right, so one way to do this is just to make a table, right? I've got my points here. And now this is my x and this is my y. So now I want to do 2x and 2y. So I want to take my x value of 1 and I want to double it, so it goes to 2. And then I want to take my y value of 2 and I want to double it and go to 4. So that new point goes to 2, 4. All right, I want to do the same thing on the next one. I want to take that 1 and I want to double it, so times 2 would give me 2. And take that 5 times 2 is 10. Now I'm going to take my x value of 3 and double it, so that gives me 6. Double the 2 gives me 4. And then I'm going to take the 3 and double it, which gives me 6. And then double the 5, which gives me 10. So 1 comma 5 went to 210, 3 comma 2 went to 6, 4. And when I doubled 3 comma 5, doubled the x and doubled the y, I got 6 comma 10. So then all I have to do is I have to graph those points. So if I go over 2 and up 1, 2, 3, 4, that would be this point here. And then I also want to go over 2 up 10. So 4, 5, 6, 7, 8, 9, 10. That's all the way up at the top. All right, my next point is over 6. So 1, 2, 3, 4, 5, 6, comma 4. And then over 6 up 10. Now, I still have a rectangle here. Okay, but remember, we have to now look at this rectangle and we have to decide if it's a rigid motion or if it's a non-rigid motion. All right, so rigid motion, remember, you move the object, but you don't change the shape or the size. Hopefully you can tell that this first pre-image and then to the image, that rectangle got much bigger, right? It doubled in the x values and the y's values. So non-rigid means it does change the shape and the size, which is exactly what happened here. So this would be non-rigid motion. Okay, now going back up to this one, up in letter A, we could have done this with a table as well. I don't think you really need to, right? But we could have listed these points as a table. So we had the point 2, comma 2. Up here we had the point 2, comma, what was that? 1, 2, 3, 4, 5. So we had the point 2, comma 5. Then we had the point 2, 3, 4, 5, comma 2. And then we had the point 5, comma 5. So I could take my 4 corners and find the x and the y values. And if you like the table better, we can do the same thing. I can go x plus 3, comma y. All right, so what am I going to do? I'm going to take my x's and add 3. So 2 plus 3 gives me 5, but then keep my y value the same. I can go 2 plus 3, which is 5, and keep my y value the same. The next one, I got to add 3. So 5 plus 3 is 8. Leave the y value the same. And then 5 plus 3 is 8. Leave the y value the same. And if I would graph that, I would get this figure that I colored in right there. I've got my points. I could draw my rectangle. But sometimes I think when you're just shifting it right 3, it's easier to just take the original one and then shift it right 3. On your homework, though, you will have some tables that you can go ahead and just move each of those points to where they need to be. Thanks.